Hey friends, welcome back. In the previous video, we introduced the SCELBI series and the plan and ideas to actually assemble the SCELBI computer in this series. And the first video will be the assembly of the power supply because we'll need the power supply to actually test some of the boards that we'll be assembling. And obviously we'll need the power supply to run the computer itself. So the power supply is basically a prerequisite for that. Before we start the assembly of the power supply, I want to remind anybody that might still be interested, the SCELBI PCBs are still available for sale at callingshow.com if anybody's interested. You can buy the whole set. There's some additional boards as well that are available. The front panel boards are also available. I have a couple left, maybe like 3 or 4. They kind of disappeared quickly. If these front panels do go out of stock, you can still make some of these yourself by using the CAD file that you can find on the GitHub page and upload it to something like PCBWay, and they can fabricate this front panel for you. The SCELBI computer requires positive 5 volts and negative 9 volts. And the positive 5 volt line requires about 1.5 amps with the basic set of boards. So basically all the boards without the memory or any peripheral boards. And I think maybe approximately 100 milliamps on the negative 9 volt side. Now, if we're going to add memory to the boards, if you're building the 8H board and it actually uses the 1K RAM boards, which I didn't reproduce, but if you are using it, I think it requires an additional 200 milliamps on both the positive 5 volt line and the minus or negative 9 volt line. So if you're adding 4, that's an additional 800 milliamps of current. In our case, we're building the 8B version or the business version. That one will be using the 4K boards, and those boards do not use the negative 9 volt line, so we only need the positive 5 volts, and that actually requires 600 milliamps for each board. So if you're adding 4 of them, that's an additional 2.4 amps of current that is required, just to keep that in mind. So basically, if you're running a fully stacked SCELBI, so if you have all of these boards and maybe 2 additional RAM boards, you will need approximately 5.4 amps of current, and that's the maximum amperage. So that's, it's probably not going to go up that high, but just to be safe, you need at least 5.4 amps of current. And of course, if you're also thinking about adding some peripherals, such as the keyboard interface and some other additional boards that I introduced in the previous video, you need additional current for that. And that is the reason why I actually went with this power supply right here, and it's a 5 volts, and it supports up to 6 amps. So I think that should be enough for our case. And I also got this other power supply, and this is this actually supports 12 volts at 1.7 amps, but it can be adjusted to 9 volts, or in our case it'll be negative 9 volts. We can adjust it with this potentiometer. These are power supplies. I'm using 2 of them, one for positive 5 volts and one for the negative 9 volts, but you can always use a single one that supports both of these voltages. I'm also going to be adding a fan, and I'll be using something like this. This is a 110 to 120 volt fan, and it requires about 0.1 amps, so 100 milliamps. And all of these parts that I have here, I just wanted to mention, you can find a list of them on the GitHub page. So to start off, actually, I want to mention that I have this enclosure here, and this is 10 by 12 by 3 inches. And it's the same enclosure that we'll be using for the SCELBI computer itself. And the SCELBI computer will be sitting on top like this. So all the wiring and the switches and the I/O ports will be running through the enclosure itself. So it'll be the same enclosure as this power supply. And the idea that I had was to basically mount these power supply units inside the enclosure, and then have this fan be mounted right over here, something like this in the middle. And the power supplies will be somewhere over here. And we'll then mount the positive 5 volts and negative 9 volt lines on these binding posts, and also we have this black one for the common. Additionally, we will have this connector. This is an Amphenol connector, and I think the model number is 86-CP4. And this is a male version. There's also a female one that will be installed in the SCELBI computer itself. So this is going to be used for power. And of course, we'll have a fuse holder. This is a fuse holder. We got a fuse here. I'm going to be using a 700 milliamp fuse. I think that should be enough. If not, we can use a 1 amp. We also will have a switch for the power, so you can turn the computer on and off, or the power supply on and off with the switch, and a cable gland. Also have this cable for the cable gland. This is just like a standard computer cable. I just cut the end off. And I also will try to install some of these lamps, and these are actual, I guess, incandescent lamps that are 60 milliamps. I thought they look pretty cool. So I'll try to use these, but you can use LEDs if you want. Just be sure to actually add some of resistors to them, just so they don't burn out from the excessive current. And we have some wires here, and that's pretty much it. So yeah, I will install the fan here. I'll install the power supplies inside the enclosure somewhere on this side. We'll have the switch, the fuse on this side, and also we'll have the binding post and the other power connector, and also the lamps on this side. So what we have to do is drill out the holes for all of this. And I already made the markings on the enclosure here, and I just got to drill it out. So let me go ahead and do that. And here it is. So as I was saying, we have the fan opening right here. We have some holes to mount these power supply units, and they'll be mounted inside the enclosure. On the back of the enclosure, we have holes for the power gland, fuse holder, and the switch. On the front, we have holes for this Amphenol connector. It'll be mounted in there. And 2 lamps and 3 binding posts. So this fan opening, I actually used something like this. This is a hole saw. This is a 3-inch one, and I just kind of drilled it out. Works pretty well for that. For these other holes, you can use any drill bit that fits your needs. You can also use something like this to drill cleaner holes. And for this Amphenol power connector, we actually have a little tab here, and the way to make that hole is to use something like this key punch. Let me just pull it out here. You basically insert it something like that. Actually, it's on the other side. And then you use this knot here. You'll basically screw this in and tighten it until it cuts through, and it makes this nice clean cut. I got this off of eBay, and I think this is a, so this is a 1 and 11/64" size, and that should be enough to work for these Amphenol connectors. And again, we'll also need to use this for the actual SCELBI enclosure, because there's going to be quite a bit of these Amphenol connectors on the back for the I/O ports. And I got this off of eBay for maybe $30 or so, and when I finish with it, I really don't need it anymore, so I might just go ahead and relist it, or just make it available for anybody else that might need it. Okay, let's go ahead and start assembling this power supply. I'm going to start off by installing these power supplies in here first. Okay, I went ahead and mounted these 2 power supply units into the enclosure. For this one here, I actually had to kind of lower the power supply into the bolt here, but I had to pull the bolt out first because it's just too tall and it wouldn't fit through here. The clearance is too low here, so I kind of had to wiggle it in there to get it to fit. But yeah, so we got both of these installed. And I think the next thing we want to install is this high power, high voltage line. So basically the switch, the fuse, and the power cord. So let me go ahead and install that. So I got the power cord connected here, coming inside, then it goes to the fuse and then to the switch. And the switch and the fuse are connected to the black wire, the hot line. And the white one just goes directly to the transformer here, to the common connection. So we need to connect it to this is the 12 volt side, or the -9 volt side. This specific power supply actually supports 12 volts or 15 volts. We just want to make sure that we connect it to the 12 volt side. And also I'm going to run some wires from this transformer to this transformer. Basically connect common to common, 12 volt to 5 volts. There's a 6 volt as well. We're just going to leave that blank. So I will do that next. One other thing that I want to mention is I connected the ground wire to this the chassis of this power supply here, and this chassis is actually connected to the enclosure, so this enclosure itself will be grounded. So yeah, let me go ahead and solder in these remaining two high voltage lines, and then we'll move on to the fan. I went ahead and soldered some wires here to the fan. Actually, I got these wires somewhere, I forget where, but they look kind of cool. Retro. So now when we install the fan, we just want to make sure that it's actually blowing in the right direction. So it has arrows here, so airflow goes that way. And we want it to blow out of the case, so out of the enclosure, so we will mount it something like this, basically, so that it blows out of the case instead of inside into the case. So let me go ahead and mount this. That's what it looks like on this other side. So we got this fan guard here with the fan. And by the way, these bolts here that I'm using, this head is called a pan head. And I thought that they look pretty cool. So if you want to reproduce the same ones, that's what you got to look for. Okay, let me run these wires to the high voltage side here and connect it. The high voltage side is finished. We can probably plug it in now and do some probing around to make sure everything is working properly, make sure the fan is working. So let me actually go ahead and do that. So I'm going to plug it in. Actually, let me make sure that the switch is off. It's in the off position. Okay. Let's power it on. this fan is pretty loud. I wasn't expecting it to be this loud. It's just whiny. Guess not too bad. Let me check the voltages. That's our 5-volt line. And the 12-volt line. I'm actually gonna go ahead and adjust this one to 9 volts. And I'm actually not gonna make it exactly 9 volts. I will actually make it slightly more, maybe 9.5 or something like that. The reason why is because we're gonna have some voltage drop anyway. I just went ahead and replaced R13 here with a 10K resistor. It's a 2-watt 10K resistor, and that's the only one that I had. I think anything between maybe like 47 or so, 4700 to maybe 10K ohm should do. But let's see what we're getting with the 10K. Let's go ahead and turn it on. Okay, so we're getting a 9.1. I think that's pretty good. Let me see if we can adjust it any. With 10K, the highest that we can go is 9.1, so we'll just leave it at that. And again, I'm gonna verify this one to make sure that we're getting 5 volts here. And we are. Okay, that's good. Okay, I guess the next thing we can do is install the low voltage lines, basically the power coming out of the power supply and going to the SCELBI computer, and also the lamps for the power indicators. So yeah, let me go ahead and start installing that. Because the first thing I'm going to do is insert all of these components into their openings here. With this Amphenol connector, and the way we want to insert it is basically there's a tab here, and whenever you make this hole, make sure the tab is straight, basically pointing either left, right, top, or bottom. The reason why is because we want these connectors to align a certain way. So the way we're gonna wire these up is we'll have pin 1 be like positive 5 volts, pin 2 and 3 will be common or ground, and pin 4 will be minus 9 volts. So let's orient it something like this. We'll have we'll have ground facing down. Alright, so I got the Amphenol connector installed there. There's like an O-ring that goes around it on the inside. That's what it looks like on this side. Next we can install the binding posts. Okay, I installed the black one here for the common wire, the ground. But I'm just looking here, and I think that might have some issues installing the lamps if I install the binding posts first. So let's go ahead and install the lamps first, and then we'll install the binding posts. And I'll be installing something like this. This is a incandescent lamp. It's 5 volts, 60 milliamps. So I want to see how that will actually work out. And I'll be using something like this to mount it in. These I got on Amazon a while ago, and I want to see how well they work with these lamps. See, we don't even need this here because we already have one directly on the lamp. So I think this goes, no, actually goes from this side, just like that. Push it in there, and let's go ahead and mount it. For these red binding posts, we want to install something like this in the hole, just so that the post itself doesn't actually contact the enclosure. Let me show you what I mean. So this part right here is the contact that will be passing through the enclosure, and we don't want it to be touching the enclosure against the body of it. And one way to do is to drill a hole that is large enough to kind of have it sit around this ledge here. But in my case, I didn't do that, so I'm gonna have to insert something like that in the hole, just so we have some sort of insulator there, like that. Finally, let's install these low voltage lines from the power units to the output ports here. Okay, I think we are finished with the wiring. I added quite a bit of solder to the connectors here where the wires are attached, just to make sure they don't get disconnected. And one other thing that I did, or one change that I made, was basically I removed the resistor on the 5-volt line because it doesn't really need it, unless you're using an LED. I'm not using an LED, so I don't need it. But on the minus 9-volt side, I added a, I think it's a 68 ohm resistor, just so that the lamps actually burn the same brightness. And I think we're finished. I'm gonna turn it upside down, or right side up, I guess. And plug it in. Oh, it's already on. Okay, let me just turn it off for now. Okay, so let's turn it on. Okay, and this is what it looks like from the front. As you can see, the lamps are burning pretty evenly. We got the Amphenol connector here for the power to the computer, and we got these binding posts for the peripherals. So the next thing I want to do is, I guess the final thing that I want to do, well, second to the final, is to add a cover on the bottom here. But I want to make sure that there's some holes here for the air to move, because the air is going to be sucked in from the bottom and blown out through the top. And also what I want to do is add some lettering here to show which binding post goes where, basically 5-volt or minus 9-volt. So let me go ahead and do that. We got the lettering on the power supply here. I actually named it as the SCELBI PSU, and we have the minus 9-volt and positive 5-volt lines here, and also the common. Also on the bottom here, I added a cover, and I also installed a basically another fan grill to act as a air intake, and that works pretty well. Also, I added these feet here, rubber feet, because these metal ones that were originally on the bottom plate were just not tall enough. So let's give it a shot and turn it on. think it looks great. So the minus 9 volt line is active, and also the positive 5 volt line. I hope you enjoyed watching this video. Don't forget to click the like button, and also subscribe so you don't miss the next videos in this series. We're gonna assemble the PCB boards of the SCELBI computer. I think the next video might be actually assembling the enclosure for the SCELBI computer, just so we have, and also the backplane, just so we have something to insert the PCBs into. So be sure to subscribe so you don't miss that, and I'll see you in the next video. Bye bye.